Today, we're interpreting graphs again, but this time we're focusing on continuous and discrete. It's on my screen already. Okay, that's not what that wasn't supposed to happen. Let me go back up. There we go. So let's start with the definitions. Okay, that's a good place to start, obviously. So a discrete graph will obviously contain discrete data. So what is discrete data? I need to stop doing this. There we go. So discrete data is data that can be counted. Okay, so if you remember when we spoke about natural numbers, we said counting numbers, right? So that's what we're going to be working with here. So it's only numbers that can be counted. It can be whole numbers, and this graph is indicated by dots that are not joined with a line. Okay, so if you see a graph that is just dots and no line, that would most probably be discrete. And continuous data is data that can be measured. So that's the difference, okay? Let's highlight this. I think this is important. Let's hope today my handwriting is a little bit more on the ball. Okay, so discrete data can be counted and continuous can be measured. Okay, so this involves real numbers other than whole numbers, obviously meaning decimals and, you know, all of that, and fractions. This graph will be indicated by dots, but they will be joined by a solid line or curve. We will discuss why just now. Now let's talk about, since we just read the definitions, let's talk about the following graphs. The first one that's up there. Score in maths. So this is a graph. Oh, this is a graph that shows the scores in maths, as well as scores of science of a bunch of grade 9 learners. I just made that up, but let's pretend it is a bunch of grade 9 learners. Okay, so what type of graph is this? Is it discrete or is it continuous? Is this graph discrete or is this graph continuous? Based on the definitions that are above, if you haven't taken a screenshot, now would be a great time to do so. But what type of data or graph do you think we have here? Do we have a discrete graph or do we have a continuous? Okay, Voltaire says discrete. There are now 29 of you in here, so I'm expecting way more answers than that. There we go. Tando, Delando, Samkelo. So are we all agreeing that it's discrete? What does everyone else has to say? There are a lot of us in here. There's Lita, there's Lindile. I see you guys. Amara, Shelo. Okay, so it is a discrete graph. How do we know it is a discrete graph? Remember, if you want to speak to me, you're allowed to raise your hands, guys. I don't have to be the only one who's sitting here speaking the whole time. That gets boring. Because it has dots. Okay, they both have dots. But what's special about these dots? These specific dots, what's special about them? Let's see. Anyone? The definitions are on the screen, guys. Okay, let's hear. Slindile.
Hello, ma'am.
Hello, how are you?
Hello. I'm fine.
What do you...
Because, ma'am?
No, you can continue.
All the dots are not joined, ma'am.
The dots are not joined. I think that's what I heard. So the dots are not joined, which would be correct, Slindile. So this is discrete data. There are dots that are not joined. And think about your marks, guys. Some teachers are very nice, I know. But personally, in my own school, I do not give half marks, okay? So you cannot get 14.5 or 14.75 as a mark. You either get 14 out of 20 or you get 15 out of 20. So that would make this data discrete. So this, we all agree, is discrete data. If this thing can cooperate, life would be wonderful. So this is this. Nope, it's not cooperating. Give me 2 seconds. Also, that's way too small. I know you guys are not going to see that at all. Let's try that one. That's better. So this is discrete. Right? Wonderful. The dots are not joined. There we go. There's more participation in the chat, which is what I want. Let's go to the next one. This is a graph that shows the time taken to get to school. So let's pretend those are like, no, let's not pretend anything. This is the time taken to get to school. So is this continuous data or is it discrete data? And give me a reason why you say it is continuous or discrete. Let's go. Continuous or discrete, and a reason. Okay, I only have one answer from Delano who says continuous. Snako says continuous because there are lines. That is true. But also, guys, what type of data are we talking about here? We're talking about time taken to get to school, right? So you have to think about it carefully. The time taken, it can either take you 5 minutes, or it can take you 5 minutes and 5 seconds, or 5 minutes and 20 seconds, or 5 minutes and 35 seconds. That means this type of data is measured, first of all. Thank you, Asamgele. It can be measured. We measure time, right? And it can have decimals, right? So it could be 5 minutes, but it could be 5,2, or it could be 5,6 minutes. Like there's a lot of measuring you can do when it comes to time. So that would be continuous data. Wonderful, guys. And more people are responding in the chat, so I love it. So this is continuous data. Okay, let's move on. This time I didn't give you a graph. Now you have to purely rely on the definitions, right? Let's do this. Let's make this a bit bigger for you guys to see. Welcome, Keegan. It's okay. It's okay. Let's make this a bit bigger. So this graph, well, table, measures the distance traveled in certain time. So in 0 seconds, you have traveled 0 meters. In 5 seconds, you have traveled 50 meters, and so on and so forth. So what type of data are we working with here? Is this discrete or continuous? Remember the definitions. When do we use discrete and continuous graphs? What do you guys think? We're measuring the distance traveled. Oh, well, okay. Well, that was a dead giveaway. If you listen carefully, then you know Simone's laughing at me because she's like, ma'am, you just gave him the answer. Thank you, Volta. I gave you the answer when I said measuring, right? I definitely gave you an answer. Thank you, Spongo Gushe, Tando. So this would be continuous data because it can be measured. Again, with distance traveled or meters. You know, when you take a tape, you're able to measure like 1,67 meters or 1,47 meters. So it's measured and it can have decimal places. It is not only whole numbers. So that would make it, Votar is laughing at me. She's like, haha, I got your hint. So this is continuous data, continuous, wonderful. Next table, I love tables today, hey? Except I don't like making them big enough for us to see. I don't know what's going on. Next table says the number of chips sold and how much those chips cost. Ooh. So we're talking about the cost of chips. We're talking about the cost of chips here. Let's think carefully. Cost of chips. If you look at that data, it will tell you, it will give you a nice, there we go. Voltaire is getting all my hints today. All of Voltaire is here thinking, I'm going to listen carefully and she's going to give me all the information I need and I'm going to know exactly what to do. There we go, guys. But also let's talk about money. Let's talk about money. Is money only whole numbers? Think about it carefully. Does money only come in whole numbers? Oh, see? So can it be discrete data? Remember in the definition for discrete data, we said it can only come in whole numbers. So if it is only whole numbers, can it be discrete data? Remember, money doesn't come in cents. Doesn't come in whole numbers. It can be counted, Kanyo, but this is where the definitions are now confusing us. Remember, I said continuous data has decimals and discrete data is only whole numbers. Think about money. Do we only have 1 rand, 2 rand? Just look at the table itself. Are those only whole numbers? Look at the table carefully. Exactly. Think about the prices of stuff in shops. It can be 1 rand 20 cents, 1 rand 99. Exactly, Neil. We have cents. So can this be discrete data? Thank you, Tando. I think Tando's like, oh, it can't be discrete data. So as soon as you think about it and you're like, but wait, this can have decimals, then it cannot be discrete data. Discrete is for counting. It's like if I say to you, how many cars are outside? You're going to go outside and say 1, 2, 3, because you cannot have half of a car, right? Then you wouldn't count it as a car. So then this would have to be continuous data. There we go. Looks like I'm in love with continuous today because that's all we've been getting so far. Okay. Can it be both? No. It cannot be both, Kanyo. It's either continuous or it's discrete, okay? It's either continuous or it's discrete. Okay, this graph measures, okay, if we can show you this graph, there we go. This graph measures temperature over a day out. Ooh, so we're measuring temperature. Okay, of course. Of course, I'm going to give you a freaking clue. Is this continuous or discrete data? Think about temperature. Does temperature only come as whole numbers? Can temperature have decimals? What type of data do you think we're working with here? Anyone? Smonguta says continuous, so does Voltari. Okay. Everyone else? 36 of you. Let's hear what we have to say. Continuous, continuous. So we're all agreeing that it's continuous. Why is it continuous? Let's see if we have a reason. See, does like, I'm running away. Hey, Asamkele says it can be measured. Yes, it can. Yes, it can. We measure temperature using, and Sanchushka said something very important. It is a solid line graph, right? Because when you think of temperature, if it is 5 degrees Celsius now, and it's 3 degrees Celsius in the evening, it's not like it changes in like 1 second, right? It declines slowly. So maybe it will be 4.9 degrees, and then it will be 4.8 degrees, 4.7 degrees, then it gets to 3. So this is definitely a continuous graph with continuous data because A, it can be measured, and B, it is a solid line. So this has to be continuous. We're getting much better at this. Continuous. Wonderful. Let's move on. Let us move on. Okay, last one. Here's a table of data that shows the number of each type of flower in a field. So in a field, we have 33 daisies, 29 dandelions, 16 thistles, 30 buttercups, 17 bluebells, and 21 poppies. Is this continuous or discrete data? Is this continuous or is it discrete data? Voltari says discrete. The numbers are whole numbers. Voltari already gave me a reason, but with a question mark. So even me, I don't know. Tapang and Lita seem to agree. Can it be both? No. Cannot be both. Siamtana, it either has to be discrete or continuous. Snako says discrete as well. Discrete, discrete. How do we know it's discrete data, guys? Give me a reason. See, Tanda also says discrete. Tanda also says discrete. Whole numbers, guys, whole numbers. And we are counting. You're counting flowers in a field. So you're going to say 1, 2, 3, 4, 5. You're not going to say 1, 1,5. Because what is 0,5 of a flower? Short flowers are still flowers, okay? If it's missing petals, it's still a flower. So it's definitely, oh, Amgele and Santrishka also say discrete. So it's definitely discrete data, right? You cannot have decimals of flowers because I don't know what type of flower is a 0,8 of a flower, right? So this is discrete. Beautiful. Now we're going to move down and jump the brain break. I'm coming back to it. Nobody attack me. I'm coming back. Okay. Yee. Okay. Now let's talk about minimum and maximums of graphs. Siamtana says it's a half dead flower. No, that doesn't count. Siamtana is hectic, first of all. Secondly, no, we don't count half dead flowers, okay? It's still a flower, it's just half dead. Okay, let's talk about minimum and maximum of graphs. What is a minimum and maximum in general? What do you know about minimum and maximums? What do we know about minimums and maximums in general? Never mind graphs. Highest and the lowest. Thank you, Tepang. Anyone else have an opinion to say about minimum and maximum? You have never heard, Siamtana, you've never heard of a minimum and a maximum. Slendila says highest is maximum and lowest is minimum. Okay. Wow, hectic. Okay, that's fine. We'll talk about it just now. So as Slendila and Siamtana have said to us, if I'm talking about a maximum, if I can write maximum, then maybe I can talk about it. Whoop. Least and most. Okay, there we go, Tando. That is the most comprehensive definition. Okay, so if I talk about a maximum of a graph, right? I'm talking about the highest point of a graph. So that would be the highest point, right? And if I'm talking about minimum, I'm talking about the lowest point of a graph. Okay, so since I said point, you guys should pay attention because when I ask you for a minimum or maximum, I want a coordinate. Okay, so if you say the minimum is 5, I don't know what you're talking about. You have to give me a solid coordinate. So let's look at the two graphs we have here. First of all, are these linear or non-linear graphs? Let's see if we remember what we learned on Tuesday. Are these linear or non-linear? Tapang says non-linear, Siamtana says non-linear. Tando agrees. Okay, beautiful, we remember, okay? So, over there, would you say, if we're looking at the y-axis, so pay attention, we're looking at the y-axis, this one, right? The one that goes up to down, or the vertical one. Would you say this point, maybe I shouldn't highlight it red, considering my graph is red, that green point over there, would you say it is a minimum or it is a maximum? Would you say the point that is green is a minimum, or would you say it is a maximum of the graph? Okay, Tapang says max, everyone else says minimum. Look at the y-axis, guys. Compare the other points on the y-axis. So let's look. So this point over here, the green point, right? It goes up to there. So it goes up to 1. Do you agree? This point over here goes up to -1. This one goes to -3. Do we see that? So are you guys telling me that 1 is the minimum? Look carefully. Minimum means lowest point. So is 1 lower than -1 and -2 and -3 and -4? Let's think about it carefully. Okay, Voltaire said max, Asamkele said max. Minimum. Oh, it's a maximum. Yes. Don't be sorry, guys. That's why we're here to learn, right? So in this specific graph, that green point will be the maximum because that is the biggest Y value you will ever get from this graph because it turned around and it's going the other way, right? This graph should actually have arrows going down because it goes on forever and ever and ever and ever. So this graph only has a maximum. So what is my coordinate for my maximum point? So we've established, yes, Tando? Hi, Tando.
Hello, ma'am. So, ma'am, I see that actually this one is supposed to be maximum, but then over at, I'm noticing the reason why I thought it's minimum is because I see 2.0. So I thought maybe 2.0 and 4.0 are the ones that are higher, and the 1 is the lowest.
I see, Tando, but the graph, does the graph get to 2.0? Look at the graph.
Also, we're supposed to look where it ends up at.
Yes. We're looking at the graph. So there
Okay.
is 2.0 and 4.0 on the Cartesian plane, but the graph only goes up to 1. And then it goes down to the negative numbers.
Okay.
You understand now?
Yes, ma'am.
Wonderful. Thank you for asking. Okay, I hope we have clarified for people, for others as well who may have been shy to ask. So the Cartesian plane goes up to 4, but the graph only goes up to 1. So it goes from 1 and then it goes down to the negative numbers. That means 1 is the maximum because that is the highest that this graph will ever reach. Nice. I'm glad you guys get it. So what is the actual full coordinate of this? Remember, we write coordinates, open bracket, x coordinates. So what is the coordinate? We've established that the green point is the maximum. So what is my coordinate for the maximum point? Okay, Tsepang says -1 and 1, but Tsepang has written it in a way that makes me cry. So it's open bracket -1 and 1 close bracket. Beautiful. Now let's go to the second one. The second one that we see over there. Does that graph have a minimum or maximum? Let me highlight it in green again, or blue this time. So this graph here, is this point a minimum or a maximum? Samkelo says minimum. What does everyone else have to say? Minimum. Okay, feels like we all get it now. This is a minimum because that is the lowest point that that graph will ever get to. So remember when we draw graphs, I should have mentioned this when we drew graphs the first time. This graph keeps going, guys. So this graph will keep going up to 5, 6, 7, 8, 9, okay? Oh, let's go back. So when says, ma'am, why is it -1 and 1? Let's read the coordinates of this point. Okay. So remember coordinates, we write them as x coordinate, semicolon, y coordinate, close bracket. This pen is too thin for my liking. Right? So let's look at the x coordinate, this point that we were talking about, this one over here. If you draw a line down until it touches the x-axis, where does it touch it? So this is 0, -1, -2, -3, -4. Where does it touch it? It touches it at -1. So there where you have an x, it touches the x-axis at -1. And then you check, where does it touch the y? This time you go horizontally that way until it touches the y-axis. And it touches the y at 0, 1. So then there where you have y, you put a 1, and that is your coordinates. Do you understand, Sibongo? If you don't be shy, just raise your hand and we'll do it together. Thumbs up, thumbs down. There we go. You're welcome. So we've established this graph now has a minimum because this is the lowest it will ever be, right? From here on, it just keeps getting bigger and bigger and bigger and bigger and bigger in numbers. So what is my coordinate for my minimum point? Siam Tanda has been waiting to answer this. Siam Tanda is like right there, right over there. So this is a minimum point. And the coordinates are 1, -1. For those who might still be wondering how we got that, let's check where it touches the x. This is the x, the one that's horizontal, right? If this is 2, then that has to be 1. So it touches at 1 for x, hence that x, the 1. And for the y, 0, -1, it touches at -1. Beautiful. Okay, now we can go to our brain break. Before we do some exercises involving minimum and maximum, let's go to our brain break. Brain break. First one, would you rather never get stuck in traffic or never get flu? Let's hear what we have to say. Yes,
Ma'am, I'd say never get stuck in traffic.
so you don't mind getting flu?
No, ma'am, I don't get sick. I get flu like once a year.
Look at everyone in the chat. They disagree. Everyone in the chat is sick of flu. Everyone in the chat is like, I am fed up with flu. I am okay. No flu for me. Thank you and goodbye. Hi, Espongo. Hi. Okay. That's fine. I see most of you saying never get flu. Same, guys. Woo! I thought I was getting flu the other day. See, Amtan is even sick. See, I'm trying to go wear a mask. You're going to make us all sick. Go wear a mask, see, Amtana, please. You're going to make us sick. I said, please. I'm kidding. Yo, I'd also rather never get flu, guys. Never, ever. Let's go to the next one. Would you rather travel the world for free or get 100,000 Rand right now? Right now, they're giving you monies. Tabang says travel. Ngovile likes money. See, Tanda.
Hi, ma'am.
Hi.
Ma'am, what I'm asking is, if the person chooses to travel around the world, does he still get to be brought back for free, or does he have to work to get back?
No, you get back for free. We're going to take you around and bring you back mahala. Or right now, you get 100,000 Rand in your account.
Okay, can I get it right now?
Right now.
Yeah.
See, I'm trying to like money. Downhill with that. It was going so well when he spoke about traveling. Can't in his mind, he's like, you know what? No, I'll just take the money. It's fine. Yeah, you're traveling for free, guys. I would rather travel. I'm sorry. I'd rather travel. Would you rather be able to fly or to breathe underwater? To breathe underwater or fly? Yes, that's how traveling works. You must get like souvenirs and stuff. Oh, this is interesting. It's fly, breathe underwater, fly, breathe underwater, fly, breathe underwater. I need to breathe underwater, guys. Ooh, I like swimming, but that thing called air, ne? So you don't even care. What if you're flying and you get injured and you fall in the ocean? It's chai. Me, I'd rather breathe on the water. Then it is what it is. Also feels like I'm not going near water. Will you be able to talk to no, see, I'm Tana, you're just breathing. That's all you're doing. Just breathing. Those people who want to swim for Olympics, imagine the advantage you'd have if you didn't have to like look up to breathe. You're just like pa, 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 pa. Nah. Would you rather constantly sneeze or constantly have hiccups? This is terrible. Simone's face just went, what? She's like,
Yeah,
excuse.
I hate like with both of them, like I can't concentrate on anything except like either getting the hiccup out or getting the sneeze out. So either way, it's like not great.
Everyone is saying sneeze. I feel like people hate hiccups. Oh my goodness. I don't know what I'd rather do. Hey, this one is a bit tough for me. I still haven't like hiccups are and they hurt. You know, your chest hurts after a while. Like after a while, you're just like, I can't do this anymore. I feel like my chest is gonna tap out. Last one, would you rather have 2 heads or 4 arms? 2 heads, 4 arms. Amara is like, this is the one for me. Amara?
Hi, ma'am.
Hello.
I think I'd rather have 4 arms so that I'm able to do multiple tasks at the time.
Okay, where are you gonna put them?
I will get my tailor to make customized clothes and keep the 2 arms.
Where are you gonna put the arms, ma'am? On your back? Come on now. Amara, please think about this carefully. I'm begging you. I'm begging. Let's hear what your classmates have to say. Siam Tanda, would you rather have 2 heads or 4 arms?
Ma'am, I'd rather have 2 heads.
How are you gonna sleep, Sia? How are you gonna sleep on your back?
Yeah, I actually prefer that.
Eee.
But ma'am,
So you have to pay double for hairstyles. If you can't see, that's 2 sets of spectacles. Ooh.
But ma'am, check. I can sleep while my eyes are open. Because while I sleep, my other its eyes will be open. You know.
You think your heads are gonna stare at each other sleeping? That's a little bit creepy, Sia. That's a little bit creepy.
Yeah, that's my
Ooh.
type.
Imagine if they have 2 personalities. Yo, guys.
That will be better because I'll never get lonely.
Sia, that's enough talking for today. Sia's creepy, guys. I've established. Sia wants 2 heads. It's fine. It's fine. Sia, do you have a twin? Maybe Sia should have had a twin. Okay, it's fine. Amara's still gonna figure out where she's gonna put the other two arms, and that's okay, Amara. Okay, I won't judge you because I put you in this predicament. Okay, let's continue. Remember, we were talking about maximum and minimum of graphs. Now we are going to talk about graphs and their maximums or minimums and what they tell us. Okay, it doesn't help that you can identify where the maximum and minimum is, but you have no idea what that information has to do with you. So let's discuss this. This is the graph showing the number of people in the park in a morning. Hey, Samkelo. You want your brain break to be 15 minutes? I see you. I see you. You're being slick. I love it, but I see you. Okay, so these are people in a park in the morning. So this graph obviously has a minimum and a maximum, right? Let's talk about a minimum first. What is the minimum of the graph that you see over here? Let's start with our minimum. Minimum and maximum. What is the minimum of our graph here? Tando says 5. Tando says 6. 5, 6. A lot of you, I'm taking you with me to Specsavers. Simone and I and you, we are going on a cruise to Specsavers with a lot of you guys. 5, 6, 7. Okay, so our minimum is 6, guys. There are lines to guide us. Okay, so that's 5. The second line is 6, 7, 8, 9, 10. So our minimum is 6. What does that mean? Our minimum is 6. Means that the least amount of people in the park were 6. That would be an expensive cruise, a very expensive one, Simone. And that's why whoever chose the 100,000 is sponsoring it. See, vision and mission. So 6 people are the minimum that you can find at this park. So what is our maximum? Maximum amount of people in the park? Molebuge didn't pay attention. Molebuge, do you see why you lose marks in a test? This is why. Those lines are there to guide us. 23 people. So at maximum, or the most number of people, the highest number of people in this park were 23 people, right? Let's see if you guys know how to read graphs. How many people were in the park at 9 a.m.? How many people were in the park at 9 a.m.? I'm just making sure everyone knows how to read this graph. How many people were in the park at 9 a.m.? Okay, let's see. That would be 7 people. Wonderful. Wonderful. So at 9 a.m., there were 7 people at the park. I would be part of the people at 11 because nobody is waking up at 6 to be ready to be at the park at 8. Not me, can never be me, guys. Okay. Now we have a graph of a person walking to their friend's house, distance and time. What is my maximum for this graph? What is my maximum for this graph? $90 what? Oh, now comes in another element. 90 what? If I was a teacher marking this, I wouldn't mark 90 completely correct. 90 what? 90 minutes? Are you sure? Thando says 90 M. What is my unit for the answer, guys? Meters. There we go. So the maximum for this graph would be 90 meters. You don't have to write it out. Whoever said 90 M is correct. 90 meters. Wonderful, guys. Wonderful, wonderful, wonderful. Now we're going back to tables because I enjoy shaking your lives and making it interesting. This is a table of data from a walk that shows the distance walked over time. First, I'm going to ask you guys, is this continuous or discrete data? It is a table that shows you the distance walked over time. Is this continuous or discrete data? Is the table continuous or discrete data? Ita says discrete, Nell says continuous. Okay, let's see what everyone else has to say. People who are saying continuous, give me a reason why it's continuous. Give me a reason why you say this is continuous data. Distance can be measured and you can get decimals with distance. Beautiful, Voltare. I hope everyone else got that. So this would be continuous data. Yes, Mobile, that is correct. So this is continuous. What is my minimum and what is my maximum? Let's write over here. Minimum, maximum. What is our minimum and what is our maximum for this? Min is 300, max is 2.4. They made it very easy for you guys because they put them at the first one and the last one. So my minimum would be 300 meters. And my maximum, I'm forgetting my units, would be 2,400 meters. Let's see. Yep. Okay, let's do these ones. We're on the graph. We're on the graph there. So this is a line graph, obviously, showing a sunflower's growth every 2 days. Okay, so is this continuous or discrete data? Continuous or discrete? A sunflower's growth every 2 days. Spongotla says discrete, Lindile says discrete. Why do you say discrete? Why are we saying discrete? Let's hear what we have. What's our reasoning, guys? Because it is counted. So you're counting the height of sunflowers? Because it has a straight line. Think about what type of data has a straight line. It is measured. Thank you, Tepang. So this is continuous, guys. We're measuring the height of a sunflower. You can measure height. So this is continuous. And what is my maximum? What is my maximum? You do not count height. Let's think about it carefully, Asamgele. If I say to you, how tall are you? Are you going to count or are you going to measure your height? Think about it carefully. Everyone who's giving me my maximum, we are all forgetting units except Tando, and you're going to lose marks for writing 20 because I'm going to say 20 what? There we go. 20 centimeters. Okay, I have a last graph for you. And I want to ask, what is wrong with this graph? The one that says elephants. Yee, that's why I don't teach English, guys. Do you hear the problems I have? The one that says elephants in a game reserve. What is wrong with this graph? If I gave you this graph in a test and I asked you, what is wrong with this graph? What are you going to say? It says elephants, number of elephants in the game reserve in each year. So in 1960, there were 20 elephants. In 1970, there were 30 elephants. What is wrong with this graph? Tanda says the years. No, the years and the number of elephants are fine, but the way this graph is drawn, there's something off with it. Think about the definitions for discrete and continuous data. Is this continuous or discrete data? That is a very nice clue that I'm giving you. And I need you guys to tell me what is wrong with this graph. What do you guys think? Look carefully. Let's start with what type of data is this? Is this discrete or continuous? Number of elephants. Tapang says discrete. Okay. Lita also says discrete. Okay, so if this is discrete data, is that graph correct? Is that graph correct? Nobile says no. So what is wrong with the graph? So we have established that this is discrete because you count the number of elephants, right? This is discrete. So what's wrong? There we go, Nobile. Since when do we join discrete graphs? We don't, right? So this graph shouldn't have lines joining it. Beautiful, Nobile. That would conclude our lesson.